Good morning, good afternoon, good evening. Welcome back to another webinar with CIQ. This week, we're going to continue on with our HPC roundtables and talking about monitoring. So we wanted to bring on a panel of people to talk about HPC monitoring in kind of a turnkey HPC environment. Thanks for coming, guys. So we'll do a quick round of introductions. I don't know if you need for it, but John, I'll start with you. You're right.
Did you just point at me saying your mic's a little bit?
Uh-oh. No, I said John.
Oh.
It's still bad.
No, we can hear you.
Cool. John, give us a quick introduction again.
John Hanks, Grisnog, do HPC stuff in life sciences areas.
Excellent. Jonathan.
Yeah, I'm a solutions architect with CIQ and I have a background in systems admin.
Greg, you're next on the screen.
Hi, everybody. I'm Greg. Been doing HPC for a very, very, very long time at this point.
Glenn.
I've been doing HPC with Greg for a long time. And so now I'm the director of scientific computing at CIQ and specialize in HPC in the life sciences.
Finally, Forrest.
Hey, everyone. I'm Forrest Burt. I'm an HPC systems engineer here at CIQ. I've probably been doing HPC for a little bit less time than some of these gentlemen here, but I'm excited to have been doing HPC for as long as these gentlemen essentially.
Thanks, guys. So I want to dive right into it. I know when you look at traditional monitoring tools in an HPC environment, you're looking at things like Nagios, RD tool, Ganglia, but what is the advantage of going to something newer like Prometheus? And I'll start with you, John.
To pick on one of those, the advantage to going anything over Nagios is not to have to deal with the syntax of the config. I don't know that many configuration syntaxes get worse than trying to configure Nagios. Other than that, this is a weird area monitoring is for me because I don't do a lot of it. I tend, when I want fine-grained monitoring from a node, I tend to go to the node and collect it in real time, not try to collect it over time. And then for the cluster as a whole, the health monitoring, Slurm handles that with a node health check. So I tend not to do a lot of monitoring, but definitely don't like configuring Nagios or any of the derivatives for sure.
Great. Anyone else have any thoughts on that?
I can speak to that specific point that for whatever reason, at some point in the past, I got myself way inside of Nagios config and got to the point where I did not find it confusing or a pain. And so often, I know there are better tools out there, but I have historically just tended to fall back into Nagios because it's what I know, it's what I know how to config, and it's what I know how it behaves. And so I look at what especially kind of the web scale people use, and a big tool like Prometheus, and I've used I used InfluxDB and kind of their whole suite of tools for a while, and I appreciate that at a kind of at an academic or an architectural level, but often find it difficult to advocate figuring all that out when I already understand the Nagios part.
I can see that. Glenn, you've got to have some thoughts on this.
Yeah, so Ganglia was like my first experience in monitoring. I still have scars. And it's not because it came out of Berkeley or anything like that, but no, it seemed to be, I was thinking about this topic and it seemed to be like Ganglia seemed to be enough to do enough, but kind of its ancient interface and it not able to really give you a picture of hundreds of nodes, for example, kind of is where I thought it was running into limitations. And so interfaces that could show you, compute nodes with a color code scale, for example, a really small amount of pixels, so you could see 128 nodes or something like that, I thought were going to be the future. And so things like Prometheus and other kind of cloud scale type of monitoring tools, I think, are more effective. And also I find when you can put things into a database, whether it's Influx or or elastic, and then play things back. Like you can play back what your cluster was doing over a certain period of time. I find that that's really helpful, particularly for trying to debug why someone's job was, affecting affecting all the nearest neighbors, things like that. So I'd be interested to hear what other folks think about what they would actually find important in a monitoring tool, right? Is it just CPU? Is it percent memory being consumed or other?
Absolutely. Forrest, coming out of a recent academic environment, what did you guys do?
I've been thinking about this in the run-up to this meeting to make sure I had the answer to this, but it's a little bit murky in my memory. If I recall correctly, we were basically just a Nagios and Ganglia shop. I can see the charts that we had in our head, or I can see the charts that we had to monitor things in my head. I don't think we were on Grafana. I'm pretty sure we were using just basically the Nagios and Ganglia stack. I don't have too many specific thoughts there. It worked for our purposes. We were a pretty small cluster, so we were mostly just looking at kind of the standards of what you would expect, CPU, that type of thing, trying to watch out for, jobs that are utilizing nodes that aren't actually spinning on them at all. Some of the stuff that I kind of did on the side as far as this went was basically just creating the custom scripts to parse what Slurm would give you about different bits of info. So that, I could see all at once what nodes had stuff scheduled on them, all that type of thing, without having to put in 4 or 5 different Slurm commands. So I had some stuff like that I had set up just kind of for my own custom thing. But for the most part, as I recall, we were basically Nagios and Ganglia, about what you'd expect.
Thank you, Forrest. Greg, I know you've got some thoughts on this area, especially after you had a shot taken at you.
Which shot was that, Zane?
Yeah, sure. No, go ahead.
Is it the Berkeley one?
Yes, that one.
Okay, just checking.
Hey, Bernard's not on the call, so I can do it.
Well, Bernard is really the one to blame.
I know.
But so when I first, so there's a bunch of kind of legacy here that I can talk about as I usually do. So when we first started doing Werewolf back in 2001-ish, there was a big request. There was a lot of people interested in not just provisioning, but also management. And there was a piece of Werewolf which actually did monitoring. And
WW Top.
You remember? And I actually just did a Google search, and because I don't have any screenshots of WW Top actually running anymore. So I was gonna see if I can. Whoops, no, not share that. I was gonna share something just so everybody can kind of see what it looked like. All right.
Let me guess. Look like Top.
Yeah. But instead of looking at independent systems, it was a real-time monitoring of your entire cluster, and you can sort by each field. This one's sorted by node name because you can see it's bold, and you can basically go through and take a look at your entire cluster. You can also sort according to idle, what's uptime, and all these things. You can find out what systems are dead, what systems are alive. But this was never hooked into like the resource management system and whatnot. But with the appropriate configuration, you can very easily have it link in to the resource manager and just show you nodes that are running a particular job, as an example. So, but this actually had a daemon process that sat on every compute node, and basically every second would query the local resources of that system, come up with how many CPUs do you have, architecture and whatnot, but also what is your current memory utilization, and you can see everything from this person has temp in there as well, how many processes are running, etc., and so forth. But this gave a really good kind of real-time analysis. Now we already talked a little bit about Ganglia, and at the time, I'm going to stop sharing now. At the time, Ganglia was really the prominent solution that was being used. One of the issues that I and other people had with Ganglia was it was using a multicast channel to do all of the updates. So you can imagine, if you're not familiar with multicast, think of it like broadcasting to a particular group or to a particular port. And so you can basically do something like every ganglia daemon that's running on every single node is listening and broadcasting to every other node in your cluster. What this means is every node, in some times, dozens or hundreds of times a second, are hearing about every other node in your cluster. Now, for smaller clusters, it was kind of convenient because every node always knew everything and you always had backup data, but I'm not sure how relevant that backup data was, but every node just knew everything. It was never, the major benefit, I guess, was that there was no configuration. You just turn it on, it jumps into a multicast channel and it starts broadcasting and receiving data. And then you can put a web front end on it and whatnot and make it real pretty. But when you're dealing with bigger clusters, you don't want all nodes listening and hearing and parsing XML from all other nodes on every single status change of that node. So it was kind of a heavyweight solution. So what we did differently with Werewolf is it was very lightweight. And even though it did create a context switch once a second and an interrupt once a second, as it was collecting resources and collecting current status and then shooting that over the wire if certain things have reached certain thresholds of changes. So it tried to be as optimal as it could on that, but there's no getting away from it. You're still causing context switches, you're causing operating system noise and jiffies. And if you're doing tightly coupled HPC, every single thing you do is going to have an effect on the overall job and performance of the system. So we tried to be as lightweight as we could. We sent a UDP packet that had everything that we need for that nodes directed to a particular head node, so no other nodes heard it. But this was incredibly rudimentary still, right? There's so much more that we could be monitoring effectively. The question is, how do we do it effectively? And how do we do it that's not redundant with the resource manager? So the resource manager is already doing some amount of monitoring. So how do we augment that with the resource manager without adding any additional load or resource consumption to that system? And so that's my real big kind of perspective on monitoring is how do we get, what is the information we need? How do we get that information without causing, latencies, bottlenecks and whatnot? And then how do we portray that and visualize that in an effective way to users?
I think it's interesting that Glenn brought up being able to go back and replay stuff that had happened in the past to troubleshoot. But then, John, maybe you don't have that need, or it's not something that's relevant, or it just takes too much time. So from your perspective, John, why wouldn't that be something that you would do, or is it just too much to deal with?
It's probably, I have a cynical view of this, of course. You back up to why you're going to monitor. If I'm going to monitor because I'm a sysadmin and I need to troubleshoot stuff, I would just rather do that in real time, run the application and debug stuff in real time to see what's going on, or look at the cluster in real time with a workload on it to see what's going on. I wouldn't really have much need for playback. Okay, but if I have a boss, pointy-haired boss somewhere who loves to click pretty things in a GUI, then that's a fantastic feature to keep them busy so they're not bothering me while I'm trying to do real work. So in that case, I would like to have playback. Hey, why don't you go look and see what the cluster was doing a month ago and leave me alone? That'd be a great feature for me to have.
Excellent. Makes sense. Thank you. There's a lot of chat going on. There are several people, I know Alan had posted in there kind of what they're doing from the BMCs, and they're collecting that from a time series database and organizing things. So there are a lot of opinions that are going through. It's great. Thank you guys for chiming in on this. Love it.
The BMC is a good point. I mean, the only way you can collect metrics from a node without impacting the node is to collect them from the BMC. Anything you do in the OS is going to cause a problem. And that's actually the last time I used Ganglia. That's why we stopped using Ganglia, because it had a severe impact on OpenFOAM performance. And so we just dropped Ganglia from the cluster completely and stopped doing that. Was when I first stopped collecting metrics on nodes.
And it's a point that Raymond just pointed out, is they have it, Ganglia monitoring 2,000 servers, and they had to have a dedicated server to do it. So it works, he says. That's very cool. So how could we help people get more value out of a more modern tool? Or is that something we should even worry about? Jonathan, I'll go to you first. I haven't picked on you in a minute. You're on mute.
I've struggled to find kind of a best practice or best in class and still fully open, I'll say, because that's a bit of a preference for me anyway, monitoring stack to point people at and say, not only is this good and it's representative of what people who know about monitoring would recommend you do today, but it's also not a huge complex thing to get deployed, because what I've run into a lot, let's say Elasticsearch as a sink for data. The last time I've tried to do an Elasticsearch deployment, not only has it had a whole bunch of licensing encumbrance issues recently, but it also very opinionatedly wants you to have a 3-node cluster to store your data in right off the bat, because it's expecting that you're going to be doing web scale work. And why would you ever have a single point of failure in your monitoring system? And finding that that kind of middle ground where you want a good solution that you could scale up in the future, but gets you up and running really quickly and demonstrates its value really early is something I've frankly struggled with. I don't know the answer to it yet. It's one of the things I was hoping to get out of this conversation.
If you think about the stuff that you really want to collect, you're talking about enough ints, maybe enough doubles to fill a jumbo frame in Ethernet. So if you set out at the beginning to just say, I want a monitoring system that will update my information every 2 seconds, every 5 seconds or whatever, and just give me enough data to fit in a jumbo frame and set that as a constraint, like you can never send more than a single jumbo frame full of information, by definition, you're going to wind up with a pretty efficient collection system, right? You've limited this down to something that, and if you drop TCP and just do it UDP and accept it to be lossy, you've made that thing super efficient at that point. That's what I would like to see. I mean, if such a tool like that existed, I would probably be interested in monitoring again. But I have no desire to set up Prometheus or Ganglia, never again. I will do some stuff with Grafana, but usually just from my Slurm controller, dumping a few, minor things out of Slurm just to see what Slurm's up to.
You're describing what Werewolf was, the WW Top and Werewolf monitoring system. But my question that I would push back is, because I haven't developed that in literally a decade and a half. I mean, it's end of life. And I haven't used one in my HPC systems in at least a decade, maybe even a decade and a half. What kind of information do we need to be exposing via monitoring to users and system administrators? Like, what's missing right now?
I will take that. At least for me, for users, there is nothing I want to expose to users. They can engage Slurm profiling and get an HDF5 file with as fine-grained metrics on their multi-node job, whatever they're running, as they could possibly want to do. So for a user that's doing troubleshooting between SSHing to the node and just what the built-in Slurm profiling does, there's nothing that I want to show those people. This would be purely for me as a troubleshooting tool to be able to see cluster-wide what's going on.
And you're a system administrator, but what about those people? What about those users? What do they need to be more effective? And is it already there? Like you brought up profiling, for example. Profiling is absolutely critical, but most HPC users that I'm familiar with don't spend much time profiling. So like, what do we need to be exposing? Sorry, Jonathan.
One of the things that I've seen be useful in the past and wish that we had more data on it is the time spent in file IO. And especially differentiating like actual data read and write from metadata. The characteristics of different file systems are different, and whether it's a clustered file system or just a remote file system or local. The biggest overlap we've had where we took some systems monitoring and made the user's life better was pointing out that if they adjusted their file IO and their IO pattern, that they would get drastically better performance for their overall application. But that's difficult to visualize and difficult to collect in my experience often with the tools that I've used.
It's great. Alan keeps putting stuff in here. I kind of wish we could have Alan pop in to kind of tell his story. They're doing interesting stuff and they're collecting data and be able to go back and do replays, multi-node MPI, even memory and CPU. So memory, CPU, and power consumptions. Thank you for adding all the color, Alan. We appreciate it. Steve's adding some stuff in. Sorry, go ahead, Forrest.
I was just gonna say, yeah, that's really interesting what he's talking about there, pulling the info just based on native Slurm APIs and the BMC network. That's pretty interesting.
Yeah, and Steve asked a question earlier about how are users managed and or monitored from either allocation, utilization, or scheduling. So being able to monitor an individual user, are they consuming your entire cluster? Like how is that being done, or do people even pay attention anymore?
I think Slurm provides a lot of that type of functionality. I know, for example, the cluster I worked on, we had, just to address one specific thing, can the user use the entire cluster? We had something set within Slurm that would only allow you to request up to 8 nodes at once from a certain queue. So I think a lot of sites would have stuff built in natively with Slurm that would allow them to keep track of, SQ as the classic command that shows you everything running, everything pending. Then yeah, that's all controllable through kind of Slurm natively.
So policies, setting policies of what they mostly can't do.
Yeah, for that kind of accounting information, what I most often see people to deploy is a tool called XDMod that came out of the Exceed project, and I know NSF at least liked it when you deployed that and liked the reports that came out of it. It made more sense in a proper Exceed environment, but we were using it as a tier 3 site as well at one point. I never got that familiar with it or that that adept at using it, but it integrated with Slurm and pulled in all that accounting data and let you show multi-user and multi-account usage graphs over time.
Yeah, thank you, Jonathan. Earlier when I said I couldn't quite remember exactly what we used at Boise State, I had X at the front of my mind, but I was wondering if it was just because I've been messing around with a lot of X11 debugging. Yes, XDMod was something that we used and produced a lot of graphs and stuff like that we were able to serve back out. So I know that, that's still popular out there.
Great, thank you. Greg, any thoughts on this before I change topics a little bit?
I'm still really interested more on the user side. John is looking at it from the system administrator, not to put words in your mouth, John, tell me if I'm wrong, kick me. You're looking at it from the system administration perspective. Jonathan brought up the storage perspective and being able to identify bottlenecks on the storage via IO locks and whatnot. And I think that's incredibly valuable as well. But again, that's not so much user. So I'm really kind of curious. So when we first did like WW Top, the reason was because users wanted to know exactly what their applications were doing. Are they effectively using the cores and the memory of that system? But what are the holes now for users? And is there anything that we need to be, any problems that we really still need to solve? And or are there tools out there that effectively do this, again, on the user side?
Our users can SSH to the node where the job is running and run top, HTOP, ATOP. I haven't ever given them access to IO top, but probably should figure out a way for them to run IO top. Any tool they can run, they can SSH to a node with a running job and run that tool. I don't know that I probably do have some users who would be happy to have that in a web interface somewhere, but the ones that are actually able to understand what they're doing when they're tuning something and profiling troubleshooting, they would prefer just to have SSH on the node and go work on the thing directly.
Is that true even for users that have multi-node like MPI workloads? Because that's where I would expect that kind of paradigm for kind of high-level application profiling through node monitoring would fall over. But maybe I've never been an MPI developer, so I don't know.
I don't have those users, but back when I did have those users, which was 10 years ago or more, they still SSH to the node. I mean, people wanted to run things like there was a debugging, there's a debugger tool that I used to use back then, Total View. Is that the name I'm thinking of?
Yeah.
Yeah, they were that, and then other debuggers that would do parallel debugging. So they really just wanted access to start that debugger and SSH to the nodes and let the debugger do the work.
It's great. Thanks for that. So kind of, Forrest and I have talked about this quite a bit, and it's an interesting topic that we don't have it on the outline. So this is going to be kind of new to most people on here, and I want to get reactions and thoughts because it's an interesting topic. Again, Forrest and I have talked about this back and forth quite a bit. What happens when we start throwing things like AI into this and having HPC have AI associated with it and being able to help with this in a more artificially intelligent way? And I'll let Forrest kind of dive into it of what we talked about and what he's seen and kind of thoughts. So go for it, Forrest.
Yeah, just generally, we kind of focus a lot on the human side of monitoring and, providing something that a person can sit there and look at and monitor and, derive insight from. To my knowledge, there's never been any effort to do, AI-driven analytics on a supercomputer. I'm talking things like intelligent scheduling, where instead of things just being governed by an algorithm, there's something actually looking and trying to decide in whatever artificially intelligent way that is developed there, where things fit in best. Like I said, as opposed to just having like an algorithm. I see the possibility that as clusters become very, very big, and we kind of stop viewing them as collections of nodes and more as like perhaps a single industrial machine that is being leveraged for a certain purpose rather than like a collection of nodes. It might be useful if we could have an all cluster way of analyzing these very large streams of info from these very large clusters at once. And I think part of the answer there might be AI to be able to derive those type of analytics from the data being generated on these clusters. And of course, some of the first things there are, is there a data set out there that we can look at, 1 million scheduled jobs and begin to, train AI over that type of thing. So I think this is something that hasn't really been explored. I think a lot of these solutions are pretty manual. And they kind of, require a human operator looking at them. But I just kind of wanted to bring up, the idea, what about, AI-driven monitoring? What about something that we have designed to just look at a cluster and see where things could be more efficient, where things could be improved, that type of stuff? Is there any efforts going on with that? Any thoughts on, connecting AI with supercomputer management?
So I don't know if there's any efforts going on, but as you're kind of describing this, where it brings my head into is if we can instrument whatever's spawning the job, so we can monitor the job in a way that we can pull in that context and feedback back into a model, we can start making intelligent decisions, or rather recommendations, as to, is this a good hardware for you to run this job on? Are you sure you don't want to give more memory to this job? Things like that. Are you sure you want to run on this architecture? Maybe you want to run on a GPU, which happens to be available right now. I think that there's a lot of intelligence that we can glean with the appropriate monitoring and modeling of that data. I would say 100% yes.
I think that would be dependent on the type of AI. So if you modern AI that we're all doing on GPUs now, it's just pattern recognition. I can't think of any pattern in my logs or any metrics that I might produce that I couldn't just grep out myself and write a simple rule for. So I wouldn't really need to train a model for that stuff. But for this stuff Greg's talking about, that's like the old AI stuff where you would do a tree search to do, to take a derivative of something to solve a calculus problem. And in that case, once you know the rules, to be able to produce a decision tree from that somebody can say, I'm going to run this job that does this. And then that decision tree produces a valid suggestion for them. There probably is a ton of use for that to present stuff to user space in a better way. So people would make, get a more optimal use out of it by being able to follow that decision tree.
That's great. Thanks, John. Jonathan?
Yeah, so I have two primary experiences with this, both reflecting different parts of what Forrest brought up. So one was there was a project at a past site where I was that ended up being someone's graduate thesis, I think, where so at the time, the Luster environment for that system was pretty unstable and kept falling over, and there were particular user workloads that would cause the luster to become unstable and crash. And so they were looking for ways to, beyond trying to figure out why it was happening in the first place, they were looking for ways to predict that it would happen. And so there was an effort to dump all of the high verbosity luster logs and file system telemetry, and then train an AI model on it to see if the AI model could predict when the luster would fail. And my understanding was that it became better than even odds, but it was an interesting academic project, but wasn't something that would be particularly useful, at least not from the data set that we had fed it, which was a single luster system with a single set of user workloads. So maybe you could provide or develop something like that you could train up for a given environment, and that it would learn the kinds of things that happen in that environment. But in terms of generalizing it for any luster environment or any cluster, it at least wasn't part of the effort. The other thing that I've seen are people trying to do AI enhanced scheduling. And all of this comes from, ultimately, if users were truthful or fully accurate about what their job was going to do ahead of time, then you could schedule the system perfectly and you wouldn't need something like AI. But they don't. They specify, friendly values for wall time and memory use and CPU requirements and things like that. And their requirement definition isn't precisely tuned to what their job will actually do in the real world. And so what I've seen are AI-driven attempts to take job history and see what jobs actually did versus what they said they were going to need, and then make different scheduling decisions based on historical patterns, and oversubscribe a node based on what the jobs requested, and try and do it based on what the jobs are actually going to require. For example, maybe they requested more memory, but the AI model has learned over time that this kind of job tends to use half the memory that it requests, that kind of thing, and schedule the resource better that way. And you can get interesting results that way, but I tend to see two problems with it. One of which is that the impact of a failure of the AI model is very high. If you say you needed 10 gigabytes of memory and then over provisioned that on a node and your job fails because you actually needed that memory and the AI model thought you wouldn't, then that's a bad outcome. And it would be bad for the scheduler to create a job failure that would not have happened otherwise. The other is that it's not just an automated system, and it's already difficult enough to get users to trust the scheduler. One of the most often, or one of the most frequent questions that we would have is, why is my job not running yet? And, we could go into detail about how the fair share scheduling algorithm works and why their job isn't working yet by plugging all of the values into the formula that determined job priority. And over time, we could, without fail, we could show them the historical records and say, look, you have been allocated this share of the machine and they have been allocated this share of the machine. And over the past month, you've gotten exactly that. And it's scheduling to produce that outcome. But that's with a very, relatively speaking, well-characterized algorithm that you can point to the values that go into it and say, this is why it's happening that way. The minute it becomes a fuzzy AI model that you just have to trust is making good scheduling decisions, I think it would become even more difficult to get the users to trust that the scheduling is fair or correct. And the worst case of that is where your scheduling all becomes reservation based and everyone is just reserving time in the cluster, and you lose out on all of the benefits of batch scheduling because, this is my time on it and then I have it all Monday or that kind of thing. And that when people stop trusting the algorithm, that's what they start doing, is trying to get dedicated time on it instead.
Glenn, you're kind of our AI guy around here, and I wanted your thoughts on this as well. And then we'll go to Chris. Thanks for joining, Chris.
Yeah, I think that the AI could be used to better, for suggestions to when someone was saying like, "Oh, we're going to submit this job," it's like, "Well, are you sure you want to run it here?" Historically, it runs better on a GPU. Maybe you should think about scheduling on a GPU, or I think that will be useful. But trying to try to beat the current algorithms at backfilling and things like that, I think are probably a bad idea and would just lead to a lot of chaos.
Okay. Chris, introduce yourself, if you don't mind.
Yeah, I don't mind at all. Chris Stackpole. I've been doing HPC for a long time, and currently I work for Advanced Clustering Technologies. And we're kind of a systems integrator and builder for people who need HPC systems.
Thank you. Thanks for joining. So we're talking about monitoring, and I hope you have some thoughts on monitoring, and any of the topics we covered so far that you want to touch on, please do.
Sure. Yeah, I actually do a decent amount of monitoring. I've been working with Zabbix in some capacity since about 2007. And I really do like that for monitoring, especially for HPC systems from an admin perspective. A couple different reasons. I monitor anytime I have a problem, I make sure to monitor it. Whether that's as simple as an SSL cert going bad, or a particular use case where we had a user who, in one aspect of their job, was writing so many small files that they would actually tank our storage solution. Just hundreds and hundreds of thousands of small files really, really fast. So monitoring those situations, and then with Zabbix, I can add in rules to perform actions. So if I notice, we had this one application that was run that didn't clean up after itself very well. And every once in a while, when it got into a weird stuck state, it would just chomp memory until it just took over the node. So, look for these conditions and then reset that service and have that do it for me automatically. So that way I'm not always having to go in and mess with the different nodes. Somebody else earlier mentioned, I got in late, so I was watching at 2x speed for a while, but they mentioned user performance data. And with Zabbix, being able to create dashboards for users that they could see, here's what my CPU usage was, here's what my memory usage was, things like that really helped, especially for those users that didn't really know what they were doing. They don't have a whole lot of skills. A lot of them, are connecting in and just writing a script or something. The entry-level ones, they really like to see level graphs. So not only just from monitoring what's going on in the network, but how the system's being used. Can I address problems before there are problems that tank the system, and have that done automatically, to even providing useful information to a user for what their jobs look like.
Well, that's great. Thanks for elaborating on that, Chris. Appreciate it.
Mm-hmm.
Chris, do you have any thoughts on AI, HPC monitoring?
I'm not sure I've got a ton of those. There was an article, I think it was Soylent News, but it may have been Slashdot recently, talking about the downsides of using AI for too small projects when your data set isn't big enough to really have meaningful conclusions. And I think there's a lot of valid points in that. Like, I can understand why somebody who, is a major company that's got a lot of data that they can churn through to make sure that their data, that the AI is acting on good data and has seen all these little use cases. But the vast majority of the time, I think we see a lot of small problems creep up. And as sysadmins, we're usually pretty good about saying, hey, this is one problem that keeps coming up, so I'm going to write a script or something to fix it for me, and then we just move on. And so when you see these oddball problems come up, that's a good chunk of our job is, oh, great, what did happen this time that I got to go figure out, something new. And so I think that's where it gets really hard with a lot of AI, unless they've seen a lot of the data. So unless we're talking about something like on the size of like Exceed, if you're pulling in all the clusters from Exceed, and you could probably get some really good idea as to what use cases for generating problems out of that.
Yeah,
excellent.
Just to touch on what I said earlier, that's one of the biggest things about this, is that I don't think there are any unified HPC data sets that could be looked at that have attempted to aggregate data of this nature. And Jonathan touches on, luster performance. That'd be a huge effort to get that from a lot of different sites. So I think that, much like, tends to be a problem with new things in machine learning, the lack of data is what would really prohibit that development for the moment, because there's no unified way to get all of Xseed to put their logs into one thing, for example, and whether or not that's even possible is another question entirely.
Sure. So we've had Alan join. Thank you, Alan.
Hey,
Nice
folks.
short notice hopping in. Appreciate it.
You guys are
So
doing a great job, so don't take any
Thank you.
criticism from my previous
No,
comments.
you've been posting a lot of comments, and I think it's an interesting segue. I mean, you have obviously a great story, and you're doing something that maybe we weren't thinking of or weren't looking at. So if you don't mind, kind of elaborate on what you're doing.
Yeah, so first I'll just go back and reinforce a point made earlier by someone else in the chat that reminded me of when we were building the databases for the first distributed computing at CDF in the early days of the grid. And we had a database administrator who said, keep your freaking monitoring off of my machine. I will tell you when it's working right. So I fully, endorse that point of view. If you know what your machines are doing, but this is the modern day and age. We're spinning off clusters as cloud jobs. We have to have automated systems to keep track of them. So what we've been working on is what I like to call precursors to AI. There's a lot of discussion about AI in the data center, and you can understand the marketing motivation for this language. But I'm first of all not a big believer in AI at all. I'll put my biases right on the table. I tell people the machines are not that smart. What we have is obscure scripting with undetermined failure outcomes. So what we don't want in the monitoring world is any of that stuff. You don't want, as John said, pretty pictures for management to click on and get bored at and never look at again. So we've been working on these kind of precursors to AI, things that could be automated. And you ask yourself the question, why hasn't it been up to now? And one very obvious limitation is lack of sufficient data. As mentioned earlier, people who implement in-band monitoring quickly take it out if they're doing anything serious, because you don't want it interfering with your HPC. So that automatically limits the rate at which you can get information, therefore making it useless for computer science purposes. We've been kind of examining the assumptions there. The first obvious thing was baseboard management controllers are way smarter than they used to be. I mean, there's 16 core ARM systems with 16 gigabytes of memory. I mean, that's the most advanced ones. The smallest ones I've seen are 4 core. So you get very decent amount of computing done just in the BMC. And then you examine why is that not being used? Well, IPMI totally sucks as a protocol, so let's not use that. And the industry has been busily making that better through a variety of open source projects to program BMCs, but also the standard Redfish standard from DMTF has a streaming telemetry feature. So let's turn that on, and all of a sudden you're getting multiple hertz of multiple measurements per second in a manageable way that scales to thousands and tens of thousands of nodes. Okay, so now that's all in the links that I put in the chat. What I'm interested in is what you guys have been talking about most recently. How do we actually instrument the code in a sensible way? And when we're talking about HPC, by and large, we're talking about Mpi code. I mean, high throughput computing is very valuable and useful, don't get me wrong, but how do we instrument Mpi code without getting in the way of it? And for that, I think we have to turn back to the Mpi community itself and look at some of the stuff being done by the Mpi projects. And Livermore has this caliper tool, but that requires instrumenting your code. So we are working on some stuff. This center that I posted a link to is an industry supported center, and we have some stuff I can't talk about yet, but it is aimed at this this goal of non-intrusive, comes with the package. You don't have to do anything. High quality. You can and you can shove it in a time series database. I'll just stop here because I've been talking too long. But
No, you haven't been talking too long, Alan. That's fantastic. And I forgot to ask you to introduce yourself. So I know who you are. So I just started talking.
Yeah.
So
I'm
yourself there,
the managing director at High Performance Computing Center at Texas Tech, and I'm one of several co-directors of a multi-university National Science Foundation-funded industry university cooperative research center called Cloud and Autonomic Computing. You always have at least one piece of jargon that your boss doesn't understand. That's the naming principle for that center. So I just wanted to put in a plug for Timescale DB. If you haven't been playing with it, if you like Postgres and you just wish it were better at time series, it is fantastic. Open source implementations are very powerful. Yes, you can get commercially supported ones, but for what we're doing, we didn't need it.
And so that data that you're collecting, Alan, are you going back and doing replays of that data? Are people asking to go back and do that?
Well, yeah, so that's actually why we put it together the way we did. We didn't know what would be interesting. What we know is that sometimes nodes become unreachable. Why? I'd like to know what was happening before that node became unreachable. What was it doing? We do not yet have a solution for the file I/O. It's a harder problem than it sounds like. But I agree with Forrest that that's immensely interesting, and so we're looking for a smart way there. But what we found was we could just look at with the BMC, you can actually ask it, how much power are you spending on this CPU package, and how much power are you spending on memory? In principle, with Redfish, we can get actually the error rates of the HCAs for the network cards. We haven't got that instrumented yet, but one thing about Redfish that people don't understand is it's more than just a replacement protocol for RPMI. It's how the components of the motherboard talk to each other. They actually use Redfish internally to compose the platform you're working on. They just don't use the HTTP parts. So the big difference between Redfish and IPMI from a system manager's point of view is that IPMI was UDP and streaming, and any one message is not necessarily going to get through. Redfish is TCP and it's deterministic, but it suffers from the chattiness of TCP. And we were thinking of trying to do clever things with HTTP3, but then we found that we were able to talk the standards organization into implementing this telemetry feature. You can just go tell the BMC, here's a list of things I want you to tell me about. And you check them internally as fast as you can, or as fast as I tell you to. And, just do server-side push to me anytime you got a result. So it totally inverts the bandwidth and gets rid of the chattiness problem. So if you, for no other reason, you wanted to learn Redfish, learn it for telemetry. And now
I'd be curious.
Yeah.
Sorry. I'd be curious in knowing more information about it, because the last time I looked at Redfish, which wasn't that too long ago, there wasn't a great standards for it. So if you're trying to pull metrics back for CPU temperature, it's going to be different for Gigabyte versus Asus versus Intel.
It's all standardized.
But they had their hierarchy is different though.
Yeah, but it's discoverable. It's like any API. You say to the API, what have you got? And it tells you this is what I've got. And then you say, okay, give me those. So it's any particular manufacturer can customize to their. So if you want to think of the design structure of Redfish, think of an outline. It's just an outline of what's in your server. And so
I guess it was that like Intel, I think, had like CPU 1 temperature, but like Asus would start like CPU 0, or somebody else would just say, you have spaces, or they would just have MB temp.
Yeah,
they were not consistent in what the actual.
And neither is the hardware. Neither is the hardware. So what you do is you go to the thermal property and say, what have you got listed under thermal properties? And it tells you, and you say, okay, I want these. In any given data center, you'll have a relatively modest number of such things, but
right, but then you're querying for every level, though, right? Because you have to query each level in order to know what the level is below it. So then you end up with these request strings that are just really long, and they're different for every motherboard type.
Yes, think of cloud services. Every cloud service out there is probably going to be different. It may be different each time you query it. And so a well-designed microservices architecture will use the discoverability features of, say, OpenAPI or async API or something to navigate that. I have a nice tool if you want. It's in our github.com/nsfcac called Redfish Prompt. Have you ever played with HTTP Prompt? It basically turns any API into a interactive session, and you can navigate through it like directories. So what Redfish Prompt does is it goes and it pulls the OpenAPI spec of the Redfish thing you're talking to, and it pre-populates that so you can navigate through it. It has, auto completion and stuff like that. I guess the short answer is yes, it's standardized. You do have to learn how to use the standard, but the benefit of doing so is any graduate student can write the code that fetches things. You don't need SNMP traps or any of that crap. And I can prove that statement because most of our code is written by graduate students. If you haven't looked at the visualization in the links, it's astonishing.
Yeah, I would like to link to that Redfish tool if you wouldn't mind, please.
Yeah. Absolutely, Chris. And we will take the links that Alan provided and we will post them with this video, so they will be available download. Jonathan, I think you had something you wanted to add.
I was just going to say that I have been meaning to get into Redfish for a while, and I would talk to the salespeople at the different server vendors, and they'd be talking up that support. But same thing, like I was talking with Nagios, I know IPMI and I'm used to using it, so I've been kind of stuck with the limitations of that. And it's really encouraging to hear about. I think you said Redfish Prompt as a possible kind of on ramp for getting familiar with the protocol and learning what it could do. And I'd be interested to know, I think this makes sense, but to say what kind of integration for Redfish we might be able to bake into future versions of Werewolf or something like that. So where it's using IPMI today, that might be a good way to get into it.
Yeah, so let me put some realism here. It's great. It solves the problems from my point of view for talking to BMCs. And the direction that we're pushing now is moving away from just the BMC to try to have APIs to talk to the MPI layers. That's our research work right now. That's definitely not ready for prime time. The other direction you can go, however, that you can do with Redfish is into the data center, which is, rack PDUs and crack units and power systems and cooling systems, and that is happening. So Redfish is no longer just a protocol for standard protocol for talking to the baseboard managing controller servers. It's a data center API. And in my center, we have a lot of work focused on trying to get automation to the point that we can put and operate data centers at renewable energy power sources remotely. I mean, we're not new to this, but we think we have some special tools. And just to, try to help save the planet and stuff. We want to, and also we have a lot of wind power out here in West Texas, right? So, we want to try to, and you really need to talk to everything in the data center on an equal basis. You can't just say, oh, I can talk to my server a lot, but I have no idea what's happening to the air conditioning. So Redfish has got extensive tools for data center automation now. I put a link in and stop talking.
No, that's fantastic. Thanks, Alan. Really appreciate it. I think we do have some questions coming in. I've seen several. One of them, yep, that's what I was going to read. So George asks, what really needs to be monitored in a cluster other than CPU and IO traffic? I think, Jonathan, you had some thoughts on that, some wishes.
Yeah, I mean, you have within the cluster, you have those things. You also have kind of memory over time and watermarks, that kind of thing. So sometimes we've seen smaller things that we're far outside of our ability to monitor, things like CPU cached hits and misses, where we saw applications behave very differently on seemingly similar CPUs that were really just differentiated by the amount of level 3 cache they had. Things like that could be interesting, but it's one of these games where you can't predict what you need to know until you have the problem, and then you don't have the information anymore. So there's kind of a whole bunch of stuff that you could maybe want to know.
Yeah,
John?
Matt?
Sorry, Forrest. I know. Anything in particular, John, that you think other than those simple things? CPU, I/O?
I think Jonathan hit on it earlier when he said monitoring storage would be really good, and there is no solution for that, and that's probably the most critical thing in high throughput computing for sure, would be to monitor storage. And I've tried tackling this before in the past and failed miserably, and I really think you're getting to a level there where the only thing in the entire mix of tools we're playing with that can answer that question is the resource manager. And with Slurm finally supporting V2 of C groups, I'm really hopeful that having jobs track I/O in C groups will finally give us an end to finding out what each individual job is actually doing with regards to I/O.
Okay, Forrest, I think you had something you wanted to say.
I was just basically going to say, I think we can broaden the category of things that we're looking for with regards to monitoring. If we, kind of look at things through an automation standpoint, just like what we're touching on with storage here. Jonathan, you touched on someone's thesis that pulled out, some interesting logs from Lustre and that type of thing, and they were trying to do analytics over that. Alan, it sounds like the system that you're putting together provides huge amounts of just all kinds of different analytics that can be looked at.
That's all good.
Yeah, I was just gonna say, well, yeah, we may have more conventional needs, like, of course we need to see the CPUs, of course we need to see, what's running, that type of thing. I think that if we did, kind of look at automation, and we kind of looked at this from the perspective of what small real-time tuning can we generate from these different analytics that a cluster is generating. If we had a way to automatically look at those, correlate them with each other, in such a way that a person doesn't have to sit there and munch through all that data, I think that would really, really broaden what we're looking at with regards to what we actually want to monitor. If something can, once again, just like Jonathan said, analyze something like a Lustre log versus, the temperatures, and, look at those different things to find correlations and, like I said, real-time tuning that may not be obvious to a human operator, but may require a computer's view of all the data at once, if that makes sense.
It does.
Yeah, so I'll add that the Slurm, of course, has this ability to work with Lustre file systems through their job stats. We found that actually remarkably difficult to turn on and utilize well, because you really have to coordinate across all your MDS and OSS servers, all your metadata and object storage servers, and then you have to correlate the Slurm job ID with activity on each of these separate machines, and then put it back together. So we almost had an implementation, but there is some stuff in the liquid tool. I love the definition of the liquid tool. Like I know what I'm doing, LIKWID. I don't have a link for that now, but I'll look for one. And then TAC, when we were talking to them about this, pointed out that they actually have an I/O limiting tool, which I'll put in the chat here, that might give people some ideas for pursuit here. But we don't have a solution there. We'd like to. We're going to try filling out the MPI stuff first, and then going back to I/O. As for what to measure the beyond CPU, well, once you get started, there are dozens of things. Just to go back to the BMC, there are 187 different quantities on our current model of Dell server that we can monitor through Redfish at the time scale of hertz. So if we need to. So you have to ask yourself what's interesting about that. So one of the most trivial ones that I think is very instructive is that you can get from the BMC is what I mentioned earlier, the memory power as opposed to the CPU power. Now, if you look at the operating system, it'll tell you how much memory you've allocated, but that's not going to tell you anything about how that memory is being accessed. Memory power is directly correlated with what you're doing to access that memory, which is, I call it memory churn. And sometimes you can get very interesting insights into what the limitations of the code are without doing a single bit of code instrumentation, just by looking at the memory power to CPU power ratio. So there's dozens of things you can monitor. The old saying, right? If you're not measuring it, you can't use it.
It's very true. Thank you, Alan. Chris, I think you had something you wanted to add.
Yeah, I'm going to borrow Henry Neiman's phrase of "it depends." I think there's a lot of users, and by users I mean just kind of users of HPC, whether they're doing some sort of administration on a smaller cluster they've got shoved under their desk, or they're running a big data center. There's a lot of people who are using the HPC architecture to do a lot of work, and a lot of them, they don't care about most of it. What they want to know is the system on, and can I run my jobs? And so your monitoring at that point is the very basics of, is the system up? Is it responsive? Is it working? But there's also a lot of other details that you do start to care about as you start to grow in your resource usage and in the number of nodes, especially if you're a limited shop, which a lot of the people I tend to work with, they're a couple of admins for a big cluster for campus, right? So time is limited. So the more that you can monitor, and I wouldn't go through and just say, all right, I'm going to set up all the data sets first. I typically grow out. So I'd start pretty small with each new cluster and then add things that I know have bitten me. Alan was mentioning power. We actually had system where we didn't have the calculation right for power, and at a certain load it would trip and we lose the nodes, right? So now I really care about, is my power level at a certain spot? Things like temperature, very important, especially when you're running a whole lot of different types of jobs, right? In a condensed space, which some of these systems that I've worked with are just shoved into a closet. So that becomes a huge difference. And you really care about that monitoring of temperature at that point. So there's a lot of things that it's hard to say, here's all the things that you should be monitoring, because it's going to vary a little bit more per group and what information you actually care about. So, I said before, I take the approach of, if it's bitten me, I want to monitor it, and if possible, automate that monitoring. And again, I use Zabbix. So, when you see this use case, fix it, and only tell me about that if you can't fix it or your attempt to fix it fails. So that's the stuff that I would really want to be alerted on, are the critical things that involve me actually having to step in. Anything I can automate in the monitoring in the meantime is great to go back through my reports and say, hey, this one node, it always seems to trip this one thing. It fixes, but it's always tripping. And it's always this one node. That's the value of the historical aspect of it. But it really does kind of depend on how much you want to do and your monitoring tool, because some monitoring tools aren't going to get you a lot. Others, you can get a whole lot. You can do a lot of stuff with Zabbix, but I'll be the first to admit it's complicated. There are so many tunables that you can add that it takes a bit of investment. But at this point, I can throw in all sorts of values, and I never really worry about the impact of performance. Generally, it's either a cluster that's not being hit hard enough to really mind, or we've already segregated the monitoring traffic to its own network. And then it's not that much of an impact. And the value of having that data is more important to me.
That's great. Thanks, Chris. I do see one question just popped up from Tron is anybody familiar with Elk? Anybody used Elk? I've seen Elk in the enterprise quite a bit, kind of people choosing that over things like Splunk for log aggregation.
That's what we were trying to do at CU, and just struggling to get the stack up and running with the staff that we had and the documentation that's available, and mostly starting with the Elasticsearch part of it.
Yeah, it's a really powerful tool, especially if you're ingesting a whole lot of data and you're trying to look for patterns in it. I've known a lot of people who are ingesting, logs from hundreds of systems, from different types of systems, whether they're web servers or data servers or HPC or whatever. And they're looking for certain types of patterns because it is very Splunk-like in that regard. For the work that I've done with HPC, it's more overkill than what I've needed before. But if somebody's familiar with the tool and can do it, that's a different story. But I would be cautious in just saying, I'm going to jump in with this monitoring tool without doing a little bit more understanding of what elk gives first.
Yeah, I've seen that one be quite complicated. Once it's up and running and you get it configured to manage and monitor the things you want, it's great, but it is a learning curve to get it up and running. I've seen people take up a year, 18 months to get it set to where it's actually meaningful to them and actually get something back out of it. So great tool. It is complicated. So we are actually up on time. We went over a little bit, and I really appreciate John, Alan, Chris, really appreciate you guys jumping on and helping us talk through this. I think we all got a lot of really good information. I know I have things to go play with and read from Alan, from your links. Thank you very much. Thanks for hopping on with short notice. Guys, we will see you next week, and we appreciate you joining us today.
Bye, everyone.